There are a few learning objectives for Lab 1. We are going to migrate a legacy application from Windows 2003 to Windows 2019, assuming you have the installation media. Sometimes you are lucky to have the legacy application installation media, but you may be in a situation where you cannot run this installation media in the newer operating system. So in that case, you need to have some kind of a method to get that application running on the newer operating system. We will use Microsoft SQL Server 2000 as an example. In real life situation, we always recommend for you to use the application vendor recommended approach. So if it is SQL Server, what you need to do is to install the newer version of SQL Server on the newer version of operating system, and then migrate the databases using the Microsoft recommended approach. But this is an example to showcase you what kind of complex application that you can move from legacy operating systems into newer operating systems. You will also get familiar with the packaging process, especially when you have installation media. And also we'll learn some basics of debugging. So let's get started. I'm connected to the correct region of my AWS console. Let's go to the EC2 section. You can find that there are two machines running. We are first going to log in into Windows 2019 target instance. Get the Windows password using the key that you created. You already securely saved this key. Decrypt the password and then remote desktop into that. So the idea is that we are going to run SQL Server instance installation media on this Windows 2019 machine. So let's go into the C drive, and under C drive EMP you will find a folder called media. There you have SQL Server 2000 installation media. Let's try to run this media first. So of course, SQL Server, when you try to run it, it will give an error saying that this app can't run on this PC. In typical scenario, what you would do is you will try to change the compatibility mode of this file to something like Windows 7 or Windows 8, and then try to run it again. Generally, you first need to find whether the application vendor has the correct solution for the new operating system. So it could be later versions of SQL Server that you try to install rather than trying to get the old package working in the newer operating systems. But this is just a simulation, and we use SQL Server 2000 as an example. In real life scenarios, you may have legacy application where the application vendor may have gone bankrupt, where they don't no longer release newer version of their installers to newer operating systems. In such scenarios, you can use AWS EMP toolings to get it working on the newer operating systems. In the case of SQL Server, for example, you don't go through this approach. You first try to install a newer version of SQL Server on EC2 and then migrate the databases. It's usually recommended to follow the application vendor's recommended approach when migrating your application into newer operating systems. We use SQL Server as an example. So let's first try to log in into this 2003 R2 machine. Due to some organization group policies that is being applied on my laptop, I cannot remote login into that. What I'm going to do is to get the password here and then log in into my 2019 machine, and from there going to remote desktop into 2003. If you are using your enterprise or your company given laptop, sometimes you may not be able to remote login into 2003 instances directly. So what I'm going to do here is to log in into 2019 instance. It doesn't have any enterprise policy applied. And then going to log in into 2003 machine from there. So let's first copy the 2003 IP address. Here I'm in my 2019 instance I logged in a moment ago. So type the 2003 address. So 2003, you cannot just copy paste the password into the window it prompts. So what I'm going to do is to save this remote desktop connection so that when I try to connect, it's going to pop up a place to enter my password where I can copy paste. So I save that one into my desktop. The username is administrator, as any other EC2 instance, and then I click allow me to save credentials. So that will allow me to copy paste the password that I'm going to retrieve from EC2 console. So click connect. Of course, I need to type the password. So go back to your instance, give the key, and then retrieve the password. So I have this password. Because I saved that connection into the desktop and asked to prompt for the password, now it's giving me, which I can easily copy paste. Accept the certificate, and we are connected into 2003 machine. So this is a brand new Windows 2003 server. What we are going to do is to run our compatibility package. So the tooling for that is available for you as an MSI package. So if you are part of AWS partner network, you will have the installers. But in this case, I have already installed this tool. It's a very simple next kind of installer. So let's start this compatibility package builder. It's a simple exe program. And then try to package SQL Server in a way that we can run it on Windows 2019. So this is the AWS EMP for Windows Server tooling. You first need to select a folder so that you can keep all the captured file in that. So in this case, I'm going to create a very simple folder called my capture and then enter. So this is where we are going to save all the files we are going to capture. The first thing we are going to do is to do a start capture that will take a baseline of the registry and the files available on this brand new Windows 2003 operating system. It will take some time. Once the capture is completed, AWS EMP tool knows what are the files that are being installed new and what has been already there before. The next step is to install the application. So what we are going to do now is to go to my computer, like before under C EMP. We already copied the SQL Server 2000 media. Click Auto Run. This will prompt for you to run the SQL Server setup. Type SQL Server 2000 and then install the database server. Ignore this message. It's just a warning. So this will kickstart the SQL Server 2000 installer. You can see that it's a very legacy application from the setup. Install it on the local computer. Click Next. Select Create a new instance of SQL Server. Click Next. Leave them as it is, name and the company. Click Yes. Server and Client Tools is the option you need to select here. Set all the default values. Typical installation is what we want. You are going to create a local system account instead of using a domain one. So you need to select under service settings, the option use the local system account. So the migration becomes very easy. Click Next. You are going to use mixed mode authentication and you are going to give a password. Give a very simple password in this case. Click Next. Click Next. This is for learning purpose. We are not going to use this SQL Server for any commercial use. So let's give something like a number of processor license to about 4. And then click Continue to install the application. So the installation is done. Behind the scene, we ran EMP Windows tools. So it has already detected the file system and registry changes that the installation made to the system as part of that installation. So let's go to the next step. Usually as part of this installation, sometimes it runs certain exe files or tooling. And if you want to capture what the changes that happens to the file system and registry as part of the application execution, you tend to run this tool. For example, let's say when you run SQL Server Management tool, and if it makes some modification to the file system and registry, which are not part of the installation, you can run here. It automatically detected all the executable files in that installation. But in this case, you don't need to run. You just click next so that we can go to the next section. In latter part of the labs, we are going to do an exercise. We are going to run this application to capture any runtime changes. So complete the capture phrase. This will take delta changes based on the baseline it took first prior to installing the software. So what will happen here is that it's going to compare what was there before and what got installed later, and then try to take the delta changes. Here you can see the files that captured as part of the installation on your left hand side. If you run any executable that the application detected as part of this installation, any changes that happen to the file system will appear on your right hand side as files requested at runtime. Because we didn't run any of the programs, you can find that there's no any files requested. You can of course make modification into what files got captured. For example, let's say you have some log files that you don't want to include in this newer media. Maybe you realize that certain Windows files you don't need to copy into the new destination. So it's a matter of like going through this tree, and you can expand it, and you can remove items, you can redirect items. You can also undo, for example, after let's say you accidentally remove a file that is important. Here we have an example where you have setup log. I'm not sure whether it's an important file, so I just leave it as it is. For this lab exercise, just leave all the files that it captured as it is and go to the next step. In this window, it shows all the registry changes that happens as part of the installation, and also any registry change that happens as part of the running of the software. Since we didn't run the software that is part of the installation, you can find there's no any runtime changes. Leave everything as it is and click next. Give the application a name. So in this case, I'm going to name it as SQL 2000. App ID is automatically generated. Of course, you can change it. But I'll just leave this automatically generated number like 3236. Don't select anything under run. So this drop down, just leave it as it is, leave it blank, and then click package application. This will now compare the baseline to what happened during the installation, and it will capture the files. So open the package. You can find that this package got created under my capture folder with the application ID. It has all the files that got installed as part of SQL Server installation. So under this SQL 2000 underscore 3236 application ID, you will find all the files along with some metadata. It has a folder called prog data that has the file changes that happen to the file system. So if you go into, for example, EMP, you will find that under all users, there are a few changes that happen. And also if you go into program files, you will find the SQL Server installation along with the binaries, the DLLs, or the configuration that went into that. So it's a very open file format. Even the metadata is in the form of XML files. Let's go into this my capture folder and then try to zip this SQL to the application that we captured. We are going to upload that one into S3, and from there we are going to get it back to our Windows 2019 machine. So we of course need to now create an S3 bucket to upload this file. Let's go into our AWS console, into S3 section, and after that create a bucket, give a name for the bucket. I'm just going to use a random name like my EMP content. So you of course need to use a unique name. Make sure that you select the right region. So this lab series I'm running in Sydney region. So I click Sydney, create next, and then create the bucket. So I have my bucket. If you go into your EC2 instances where we are running this lab, you will find that they have an IAM role attached into them. So this role gives you permissions to assume certain role permissions. Like one of that one is S3 full access. So you can run some command line AWS CLI or AWS PowerShell command inside these machines to interact with AWS. So go to Amazon Web Services and select Windows PowerShell for AWS. So it will load AWS PowerShell tools. Go into my capture folder, and then we are going to upload that zip file into S3. So type write S3 object, give the file name. In this case, it's SQL 2003.230.zip. Give the key for S3 object. And then of course you need to give the S3 bucket where you want to upload this content. In this case, it's my EMP content. Press enter, it will upload the file. So what we are going to do next is to download this S3 object, the zip file that we uploaded into the bucket from our Windows 2019 server, and then try to install this package. Back in my Windows 2019 destination machine, I'm going to select Amazon Web Services and go for Windows PowerShell for AWS. That will load AWS PowerShell modules, which you can use to download the S3 object. So type read S3 object, bucket name that you created a moment ago. Key is SQL, whatever the key that you gave when you upload the file. So in my case, it's SQL 2003.236.zip. Name of the file, and I'm going to download this file into my ctemp folder. So once you have the file, unzip it. And here you can find some executables along with some metadata. We will go through them at later part of the labs. So open command line. What we are going to do now is to install this application. So go for your folder that you unzip. We are going to run this exe called compatibility package deploy to deploy the software. So we already know that we have the files we needed. So let's run this. To run the package deployment, you need to type compatibility package deployment. If you need the help, you can just type help. So what we are going to do is to run this exe with deploy dir as c my app. So that's where the application is going to copy or save the files, and then type accept end user license agreement, EULA. You can install the registry under user or machine. By default, it's installed under machine registry root key. All looks good. Unfortunately, there's an error that it gives when it tries to install. So this is intentional. I leave it as it is. So it says that there is already a service called Microsoft Search, or there's a name collision. The reason for this is if you search for your Windows instance, Windows 2019 services, you will find that there's a service already running called Microsoft Search. And this deployment package is also going to install something called Microsoft Search. So if you go to services, you will find that this service. What we want to use is the existing Microsoft Search on the new operating system. So what we need to do now is to remove this installation of this older version. So to do that, you go for these services. So that's an XML file. So this lists all the services that this is going to install as part of the deployment. So of course, what we need to do is to remove one of the search one. So of course, we need to have MS SQL Server service. We want to have MS SQL Server AD helper. But what we don't want is this MS search, because we already have this one in the new operating system and it seems to be working fine. So let's remove this. Make sure that you type Control S to save the changes that you make. You can do it from here. So the shortcut is Control S for the Notepad++. So close this. And now, of course, you need to uninstall the one that you install. You can do it through add remove programs and then look for this application, in this case SQL 2000, and then click uninstall. But the recommended approach is that use the command line tools to uninstall it. So back in my command line, let's clear this screen. What we are going to use is the same command, compatibility package deploy, but /u to uninstall the changes that we made to the system. So this will uninstall all the shortcuts, all the binaries that installed. Then of course you need to make sure that the folder that you created as part of this installation is going to be empty. So we are going to execute the same command because I decided that I'm going to copy the files to the same folder, like see my app. Make sure that it's empty. Sometimes there can be some logs or some changes that you made. Alternatively, you can just delete this folder and then try to run it again. So type the same command, but this time it's not trying to install MS Search, so it will successfully install the application. So the installation is successful. Next, we need to go and then check whether we can start the SQL Server 2000 on this server. So you can find that there's already some shortcuts being created. So we have this service manager. Click that and then try to start the service. Remember, we could not even run the setup on this machine. Now we have this SQL Server Manager running on this Windows 2000. Click Start. That will start the SQL Server service. So it's successfully started. Now you have a running instance of SQL Server. If you go to the services, you will find that MS SQL Server is now running successfully in this machine. So we managed to get SQL Server 2000 working on our newer operating system. Let's next go and explore what are the changes that happen into this newer operating system. Let's now try to briefly understand how the internals of this migration work. So if you go into your Start menu and then select Microsoft SQL Server and then select Server Manager, which we just started, go for More and then open the file location. This will give the list of shortcuts that this installer or our deployment created. And then select this and go for Properties. So here you have a target. The target points into my package run.exe. So let's open this here. So this is what that command says. The target is compatibility package run.exe along with the run condition as run3. If you go into CEMP, there's a folder called Tools, and open this Process Explorer. You will find that there is this exe file called compatibility package engine.exe. So what happens is when those shortcuts are clicked, it's first going to start this exe and then it's going to span some other exe as child processors. So in this case, we know that our SQL Server Manager is running. So it is running as a child processor of this compatibility package engine. So the beauty of this one is that all the file request and the registry key request coming from this SQL Server Manager can be redirected based on what this compatibility package engine is configured to do. So what it does is there is a special XML file that identifies what to run when it run this command with the parameter run condition as run3. So if you go into your, let's say to your location where you install this application under C My App SQL Server, there is a XML file called programs.xml. So let's open it with Notepad++. Here you can find that it says run 3 corresponding to this exe file over here. So every time when that shortcut is clicked, the compatibility package runner is going to look for this entry and it's going to execute SQL Server Manager exe with these file arguments. Run 3 or run 4 may be another one. So there could be another shortcut. So if you go into your shortcut folder, so let's say the profiler is run with run 6. So run 6 corresponding to this entry in this node. So you can do the redirection for your shortcuts by changing this program XML file. Then there's another redirection that happens based on this XML file, which we call the redirection.xml. So if you open it with Notepad++, you'll find that it has entries to redirect files as well as registry entries. So these are all file system redirection. So any request that is coming for this folder, for this file, will get redirected into proc data, program files, common file system, OLEDB, MSCDB, DLL. So this is a relative path. So the redirection XML file is here. So the proc data is here. So you have the program files under common files, for example. You have a system folder, OLEDB. So this entry corresponding to MSMDCB80, so this DLL. You can add the redirection, you can remove the redirection by modifying this file. It's a very open file format. There's nothing proprietary. It also has some registry entries here. So all the registry entries that is coming from here will get mapped into the right location. Registry entry is a bit different. So if you go to regedit, you can type regedit here, or alternatively you can type run and then type regedit. That will open the registry editor. Let's close this window. And here you can find that under current user and the local machine, there are some entries that got created as part of the deployment. If you expand this, you'll find under software, there's a folder called AWS EMP and one called compatibility package. So if you install like 2 or 3 software on the same machine, you will find it. So you can find that the folder for this application is SQL 2000_3236, same as the application ID we gave when we created the package. Under that you have some entries. So what will happen is that when the redirection file points into the right registry entries, it will look for these locations instead of, let's say, going into the original Windows location. You can of course redirect. So if you remove an entry here, it will not get redirected into these locations, but it will go into the operating system levels. Similarly, you have one for local machine. If you go under software, under AWS EMP, there are some entries being created as part of this deployment. So that's how the registry redirection works. File system redirection we already discussed, and that allows you to, for example, selectively direct certain registry entries that are conflicting into your own isolated location in the registry, and also certain files. For example, there may be a newer version of this DLL for the Windows that conflicts with your legacy application. So instead of directing the API calls that is coming for legacy DLL into a newer version, it can still use the legacy DLL as it is. You have limited credit available in your AWS account to execute these labs. So make sure that once you are done with the labs, that you stop the lab 1 instances, so that you are not going to incur a lot of cost. So let's stop these instances. And then if you are planning to do the lab 2, you can start the lab 2 instances from here and then start.